Hello everyone. This question asks us to find the equations for the two tangents line for this curve. Given the curve as y equal to 2x exponent 3, subtract 6x squared, subtract 2x plus 1. If I graph this curve, it has this shape. Okay, so let me trace this shape for everyone. So it has shape like this. So according to this diagram, you see that this curve has two lines tangent to it at this point right here and at this point right here. So let me trace this two tangent line for everyone. Okay, so it should be like this, and it should be this one as well. And the question indicates this to us. The question said that these two tangent lines are parallel to this line. Okay, and when it's they are parallel to this line, and this line has the equation as 2x plus y equal to 24. So I'm going to label this in a second. Okay, so right here I should have this one labeled as 2x plus y is equal to 24. Okay, and given this two tangent lines are parallel to this one, so this provides us with the key to figure out the slope, right? So if you manipulate this equation here and write it in the form of y equal to mx plus b, then you can easily figure out the slope of this line. Because they are parallel to each other, if you find the slope of this line, you can find the slope of this two tangent lines. So the purpose of finding the slope of two tangent lines is to solve for one unknown in the equation that you have to use. So if you need to find the equation for a straight line, then you need to use these formulas, right? Y minus y1 equal to m multiply x minus x1. So in order for you to find the slope, how do you find the slope? So that means you have to differentiate dy over dx equal to the m of the tangent line. So if you evaluate this at a certain value of x, you can find the values for this. So I should write it here. So x is equal to certain value, then it will give you the actual value for the tangent. Okay, so then in order for you to write the equation in ax plus by plus c's form, in general form, then you must have the point. Okay, so you must have x1 and y1. After you find the equation for this line using this formula, then you can manipulate that equation to put it into this form. So basically, your immediate step that you need to differentiate this equation right here. Before I differentiate, I might as well pull this equation out. Okay, I may as well immediately manipulate it to get to y equal to mx plus b, right? So this is the one that I want to remind everyone. And if I write this one as mx plus b, I got 2x plus y equal to 24. Then I should have y equal to minus 2x plus 24. So therefore, the slope is equal to negative 2. So we can conclude right away that the slope of the perpendicular, the line parallel to this is negative 2. Therefore, the slope of this two tangent line is also equal to 2. So I can put here as mt equal to minus 2. Because given this line, okay, so this one can be line of tangent 1 and line of tangent 2. So we have L multiplied with the LT1 parallel with LT2. So therefore the MT is equal to -2 because the slope of this line is equal to m of L is equal to 2. Okay, so the slopes should be equal to each other when the other lines are parallel to each other. So having the value of this slope, you know that it's very much similar to your dy over dx in this case. So this provides us the key to continue with this question, right? Okay, so now we can differentiate this equation and see what we get. So I got y equal to 2 times x to the exponent 3 minus 6x squared minus 2x plus 1. So dy over dx will give me 6x squared, subtract 12x, subtract 2, plus 0, because derivative of 1 is just equal to 0. Okay, so at this point, I know that according to this equation, I need to have y1, I need to have m, I need to have x1 in order to substitute into these formulas to figure out the equation for the straight line. Then I have the value for the derivative, which is -2. So I will immediately substitute this in here. Okay, so then I will write this one as -2 equal to 6x squared minus 12x minus 2. Okay, so this one to solve for x. Okay, then what you do is I can put this equal to 0, and I'm going to move everything over to this side of the equation. Okay, so here I can see that and that cancel out, right? Okay, so if that cancel out, it means that I am going to have 0 equal to 6x squared minus 12x. Okay, so this is a quadratic equation, right? This is an incomplete quadratic because you are missing the value c over here. So what does the quadratic equation represent? Or what does it tell you in this case? In solving for a quadratic equation, you know that if you have x squared, it means you must have 2 solutions for x, right? So 2 solutions for x. So if I want to solve for the incomplete quadratic, I can just factor. Okay, so if I factor, I should have it as 0 equal to 6 x squared minus 2x. Okay, so at this point, I can divide both sides of the equation by 6. Okay, so this side is just 0, and this one cancel out. So I have x squared minus 2x left, right? Okay, so the next step is you want to factor out the x. So 0 equal to x minus 2. So in this case, what you have is solving for an incomplete quadratic. You should be able to factor, and one of that solution has to be equal to 0. Okay, so in this case, you can argue either x equal to 0 or x minus 2 equal to 0. So you can have 2 solutions for x in this case. So therefore, x is equal to 0, or you have x equal to 2. Right, so because x equal to 2 is coming from x minus 2 equal to 0, therefore x is equal to 2. So at this point, what you do is you have to argue. You have a product of x multiplied by x minus 2, and the other side equal to 0. In order for you to have a 0, one of this has to be equal to 0, but you don't know which one. So you either have x equal to 0, or you have x minus 2 equal to 0. Using that argument, you can set this x minus 2 equal to 0 to figure out x equal to 2. Okay, so you have 2 solutions for x in this case, x equal to 0 and x equal to 2. So let's go to our graph to see what we have. Okay, so x equal to 0, probably right there, right at the origin here. When x equal to 2, you will have a solution for y. Right, so up there. So when x is equal to 2, you will have another solution for y, which is somewhere here. Okay, so honestly, I think I should fix this, okay, because I don't think I would just leave it like this, because when the tangent touches the curve, it should touch it at 2 points here. So I'm going to, this should be 1 point that is touched right there, okay, and the other point that is touched is just right there. So if I highlight it with purple, it's probably too thick and it shows that it cuts the curve at 2 points, but it should touch the curve, which is only 1 point. All right. Okay, so let's continue on with what we have. So once you have the value of x equal to 0, okay, and x equal to 2, you can substitute it into the equation for the function that given to you as this function here, this function, okay, to solve for y. Okay, so I will have to divide this into a 2 part. So when x is equal to 0, then y of 0 is equal to, so let's rewrite our equation again. Y equal to 2x to the exponent 3 minus 6x squared minus 2x plus 1. So when x equal to 0, y will be 2 times 0 to the exponent 3, subtract 6 times 0 to the exponent 2 minus 2 times 0 plus 1. So you can see right away that it's equal to 1. Okay, so in this case, the point that I work with will be 0 and 1. And the next one is when x equal to 2. So y of 2 will be equal to 2 times 2 to the exponent 3 minus 6 times 2 to the exponent 2, subtract 2 times 2 plus 1. Okay, so doing this, I should have x equal to negative 11. Okay, so negative 11, so I should have 2 and negative 11 in this case for the 2 points. Right, so you can easily figure this out as negative 11. You can see that this is 8, is 16, negative 24, minus 4 plus 1 is negative 11. Okay, then at the point of 0, 1, okay, and my mt is equal to minus 2. So I can write it as y minus 1 equal to minus 2 of x minus 0. Okay, so let's remind ourselves of y minus y1 equal to mt x minus x1 in this case. So then what we have is y minus 1 subtract 2x, okay, and then 0. So in this case, what I have is plus 2x plus y minus 1 is equal to 0. So this is one equation, okay? So in general form, don't forget that. So when it's in general form, a is equal to 2, b equal to 1, and c is equal to minus 1. So the next point is at 2 and negative 11, okay, and mt is also equal to negative 2. Then what you do is you write y minus 11 because we using that form equal to minus 2 times x minus 2. So we are going to distribute the term on this side, so negative 2x plus 4. So again, you move everything over to this side of the equation. Then you should have it as plus 2x plus y plus 11 minus 4 is equal to 0. So in the end, your equation will be 2x plus y plus 7 equal to 0. So this is the other equation for this tangent line in general form, where a is equal to 2, b is equal to 1, and c is equal to 7. All right, okay. So let me go back and recap what we have done. All right, okay. So this particular example asking us to find the equation in general form of two lines. They are parallel to each other. They also the tangent lines for this equation, for this function. And they give us another line to work with. They give us this line right here, and they give the equation for this line, and they say this line is parallel with two tangent lines. So again, to find the equation of the line tangent to the curve, you know that you can differentiate dy over dx. If a point is given to you, substitute into the differential equation, you can find the slope. But we don't have the slope in this case. They give us another line to work with, and this line is parallel to this two tangent line. The key to find the slope is in here. So I'm going to manipulate this equation to put it into this form, because if I put it into this form, I can read the coefficient of x as the value for the slope. So I did that. I found the slope for this line as -2, and I know that they are parallel to each other, so I can pull out that the slope is the same if they are parallel to each other. Okay, so the slope representing dy over dx. So after I differentiate this equation, dy over dx equal to -2. So I substitute -2 in here in order to solve for my points. Because basically, if you need to find the equation for a straight line, you are using these formulas. Okay, so this is the equation for finding the equation of the straight line. This one is called the point slope form. So you have a slope, you just need a coordinate here. A point x and a corresponding y. Then after I found this, because I'm working with a quadratic equation, I end up with the two solution for x. With the two solution for x, I should have two solution for y. With two solution for y, I substitute that into here, found two solution for y. And with that 2 points, I can find the equation for the tangent line. And the two tangent line we found out this. So, and then they both have the same slope of -2. Okay, so right here is the point x equal to 0 and y is actually equal to 1, which is pretty close. So when x equal to 0, y equal to 1, then the equation for this line is equal to 2x plus y minus 1 is equal to 0. Okay, and the next one is when x equal to 2, right there is 2, y is equal to -11, which is pretty close, right? And the equation for this one is 2x plus y plus 7 equal to 0. So again, I also want to emphasize to everyone that if you write the equation of a line in general form, the coefficient a, b, c, they have to be integers. Okay, so just to keep that in mind. I don't think I need to go over anything else. I think everything looks pretty good here. Okay, the algebra is pretty simple. There isn't any fraction for us to worry about. Okay, so this question looks a bit complicated, but if we understand the concept of differentiation, so if we take derivative, what does that mean? You ask yourself that question. Taking derivative means that I am finding the slope of a line tangent to a curve. If a point is given to me, then I can substitute that value into my differential equation. I can find the slope, right? So why do I find the slope? Because the slope enables me to figure out the equation for this tangent line. But besides having the slope, I need another point. So the point is not given to us, then there must be a clue somewhere in this question providing me with either the slope or the point in order to work with. So if you are given another line, then you can manipulate that equation to figure out the slope. And then after you have the slope, understanding the value for the slope is actually e dy over dx, then you can substitute that into your differential equation and you can solve for the unknown. Having one unknown x is so simple that for this point x, there must be a corresponding value for y. And how do you find a corresponding for y? Is to substitute into this original equation for your functions. All right. Okay, thank you everyone.